Do you know what a common mode choke is? Well, a lot of you do and a lot of you don't. If you want to know what common mode chokes are, what they do, how to make one, and how to test one, so you can test the ones that you've got to see if they're actually doing what they're supposed to do, and you can see if the ones that you actually make are doing what you actually want them to do. If you'd like to learn all that, please continue to watch this video. Kick back and relax, and we'll get into it here in just a second. My name is Dave, and this is my channel, Ham Radio GMRS Test and Review. My call sign is N8DAV, and the motto for my channel is one test is worth 1,000 expert opinions. So today I'm going to review this little test rig, or test jig as they call it. This is from a company called Halibut Electronics. This is a pretty cool little device here. This is the back of it, and I'll explain to you exactly what it does. This jig, I'm going to call it a jig. They call it a rig, but to me, a test rig is something that does testing. Now, to me, this doesn't actually do the testing. This holds the pieces that are tested in the proper place and provides electrical connectivity so you can do the testing. But the NanoVNA, which is the other piece you're going to need to test all your common mode chokes, they do the testing. So to me, this is a jig. This sets up everything where the NanoVNA does the actual testing. So to me, this is a test jig, not a test rig. All right. So what this is a very, very, very neat little device. What it has is it has two N-type connectors right here, two B and C connectors right here, two SMA connectors right here, two banana plug and bare wire connectors here, and two UHF or VHF connectors, which are of the SO239 type for using with your PL259 connectors that are on your coax more than likely. And that's how you connect, or where you connect your choke to, either the N connectors or the SO239 connectors, whatever. On the back is where you connect your NanoVNA with these two SMA connectors. And you see these switches? These switches are where the magic really happens on this. What you do is you calibrate your NanoVNA to this board. So with these switches, you do the calibration. You don't need those little calibration pieces that come with the NanoVNA. You actually calibrate the NanoVNA to this board, and you set it up to read attenuation. And with this jig, once you connect your common mode choke and your NanoVNA, then you can test all your common mode chokes and see how well they perform. And this is just it's a great little device. Now, this comes from a company called Halibut Electronics. The URL for this is electronics.halibut.com. Now, if you go out there, you will find that they have a few products, this being one of them. And there's also another common mode jig for things like your USB-C and USB-A cables. So all your USB cables, you can test those, and you can also test them to see if you're getting noise through your USB cables, that you can put the little beads on them, the little ferrite beads, and you can see how much attenuation you can put on those as well. It's really pretty cool. I'm thinking about getting that jig as well, because I have one, and just only one, USB power cord that provides a little bit of 60 cycle hum into a piece of ham radio electronics that I use. And it's not bad. It's not so bad that I'm going to get really anal with it, but guess what? I might just do it because you know what? I'm all about all these test things, right? I'm all about testing, and I'm all about results. All right. So next time you see me, I'm going to have you in my lab, And I'm going to show you how this actually connects to your NanoVNA and how to calibrate your NanoVNA to this board. And then what I'll do is I'll do a second video, which will come out sometime later, showing you how to actually use it to test your common mode chokes. All right. So let me get right back to you, and we'll get right into it. Just kick back and relax. Be right back. If you like my content, please consider subscribing to my channel. I would really appreciate that. And if you want to be notified of any more videos that I put out, please click the subscribe. After you click the subscribe button, please click on the bell icon. That way you'll be notified every time I release a video. I average about 2 videos a week, so actually I think that's a lot more content than a lot of creators are putting out. So anyway, I would really appreciate all that. It helps the algorithm recognize my channel as being a good one, and I think that it's a pretty good channel. So anyway, I appreciate the support. Thank you very much. All right. So, some of you may not understand completely what a common mode choke does. And so basically what happens is that when you have an antenna, especially an unbalanced antenna, but that does happen with balanced antennas as well, when you transmit on the antenna, the signal goes up the coax, the center of the coax, and some of that RF energy can come back towards your radio on the shield of the coax. And so there is a couple of trains of thought on this. Now, with some antennas, like let's say an end-fed antenna, the end-fed antenna does not have a counterpoise, and it does require a counterpoise. Don't let anybody else tell you otherwise. If you don't put a real counterpoise on there, and I noticed that some Ununs that are sold don't have a connection to put a counterpoise on there. So if you don't put one on there, then what you need to do is you need to use the coax as a counterpoise. Now, counterpoise don't need to be anywhere near as long as the antenna itself. In other words, it doesn't need to balance out the antenna as far as length and physical electrical wire is concerned. So basically, the train of thought is you multiply 0.05 times the highest band that your antenna is designed for. So that length should be your counterpoise. Well, if you're going to use, let's say I run an 80-10, an 80 meter, 10 meter end-fed half wave. I ran an 18-foot counterpoise. I believe I actually set it out to 20, but I figured it out right about just under 18 feet. And so if I didn't run that counterpoise, then I would need to have a good just about 18 feet of coax from the feed point of the antenna before I put my choke on. Now what the choke does is it attenuates that signal, or in other words stops that signal from coming back into your shack and back into your radio. If you allow the RF to come back into your shack and back into your radio, it can cause a lot of problems for you. It can cause electrical problems. It can cause shock problems. I had, when I first did my very first 4010 end-fed half wave, I didn't use a choke, and all of a sudden I was getting little shocks as every time I touched my microphone, or if I touched the case of the radio. That's a sign that you've got RF coming back into your shack from your antenna. So I put on a choke, and what I did is I put it at the feed point, and then all of a sudden my SWR wasn't all that great. And I took the choke off, and my SWR got better again. And I couldn't figure out exactly what was going on. I wasn't sure about chokes back then, and so I started reading about them, and I put a counterpoise on, and then I put the choke back on at the feed point, and everything was just fine. So and then I didn't have RF in the shack anymore. There's another train of thought that you might also want to put a choke right at the back of the radio. I'm it really depends upon if you're really having problems. Like with me, I had a touch light that, the kind that you just touch and it turns on. And every time I transmitted, it would turn on. So I had to put a choke on the back of the radio, and then that stopped that from happening. But there's also a train of thought too that if you're having RF issues like that, that maybe you should also put a choke at the feed point into the shack. In other words, one at the feed point if you have a counterpoise, or farther down the coax from the feed point, the approximate length that it needs to be if you're not using a counterpoise. So you can use the coax as the counterpoise, and then put one at the feed point into the shack, and then of course then one at the back of the radio. That would be probably the most optimum way of utilizing chokes. Now, what about chokes? Well, I have been making and testing my own chokes, the ones that I've bought and the ones that I've made, and I've been finding some very interesting results from all the testing that I've done. First of all, the chokes that have been straight, in other words, maybe a foot and a half long, with 5 to 7 ferrite beads on the outside, and it's just a straight piece of coax with a male and female connector on the ends. That works okay, but I also found that if you use the toroidal ring and wrap your own coax through that ring, I get much better attenuation than with the straight one with 5 to 7 of the with the ferrite beads on the outside, those snap-on beads. It's not that they don't work, or they're just, the attenuation is much better with the ring, with around 10 turns through the ring with the coax. One of the things that I found is that most people consider a minus 25 dB attenuation to be about as good as you're going to get. Anything better than that is excellent. Anything less than that is probably not enough. So what I found was, with my very expensive straight shot chokes that I bought from another ham, that I was only getting minus 20 dB attenuation. Now, while that's okay, if you've got real bad problems, or want to keep any problems from happening, you really do want to stick around that minus 25 dB attenuation if you possibly can. So this is something that you need to take into consideration. Well, I made my own chokes, and I'm getting a very flat curve, minus 30 dB attenuation all the way from 80 to 10. 80 meters to 10 meters. Now, it's not exactly flat, and it's not exactly 30 dB. It varies 1 or 2 dB from one end to the other. But that's excellent. That's excellent, excellent, excellent. That means the entire length of the 80 to 10 meter band that I use this attenuator, this choke for, attenuates a minimum of 28 or 29 minus 28, minus 29 dB all the way across all the bands that I work on. So I can't ask for anything better than that. I made that myself. And in my next video, I'll show you how to make one of those. And I'll show you all the different, I'll show you all the different attenuations. Now, so far I've only made 2. I made one with RG316 coax, and I've made one with RG58 coax. And they are slightly different, not enough really to make any difference. However, they are different very slightly, and I will go through those numbers with you in the next video. So those are things that you need to take into consideration. I bought and paid for 3 very expensive chokes, and they're the straight shot type with the ferrite beads snapped around the outside. And I'm not extremely happy with the attenuation that I get from those. Minus 20 dB is not bad, but I think for the amount of money I paid, I should be getting a lot more, considering I paid a quarter of the price for materials to make my own, and mine are doing right around minus 30 dB all the way across the band. So I'm convinced that the homemade type are much better. Now, I also bought one from AliExpress, and it was very interesting. It's a much smaller toroid ring. Excuse me, I'm having a hard time here. And I don't know what material they used, but they used RG58 coax in there, and I think they had either 8 or 10 turns throughout the whole thing. I'm not sure how they did it. I think they had to add one of the connectors onto it after they finished wrapping it, because there's no way they were going to wrap it with the connectors already on there. And it dips way down to minus 40 dB right at the 80 meter band, but then it just zooms right back up to, I think, if my memory serves me correctly, to only minus 10 or 12 dB up at the 10 meter band. So you can see different materials of the toroid ring or ferrite ring, whatever you want to call it, and possibly the coax too, all make a difference in how it attenuates your signal. So again, in the next video, I will go through all of that with you and show you all the different curves and everything that I got on my NanoVNA. Very, very interesting stuff. I highly recommend that you make your own. It'll cost you about 20 bucks in materials. I know that sounds expensive. I know you can buy one for maybe a little bit less on AliExpress, or maybe a little bit less on Amazon, or maybe right about 20 bucks on Amazon. I think I bought one on Amazon for, I believe it was right around $22. And they used a Mix 43 material for the ring. I'm only using Mix 31 for all my rings, and so that covers all the bands that I work very, very well. I can't complain. All right, so when you see me next, you'll start seeing how I work with the NanoVNA, how I get that set up, and how I get it calibrated. All right, be right back. All right, here's the back of the common mode choke test jig, and I'm just saying test jig, not test rig. All right. So what we have here, this is port 1, as you can see. This goes to port 1 on your NanoVNA. Port 2, which is over here, this goes to the port 2 on your NanoVNA. Now you notice I have a series of switches here. I have the center switch, and it can either be set at the top up for isolation or down for through. When you calibrate this board, you set all of the switches up to begin with, and then I will show you how to set them for when you calibrate your NanoVNA to this board. All right, so basically that's really all you need to know on the back side here. And let me get everything hooked up for you, and then I will go through the actual calibration of the NanoVNA. Be right back. All right, in order to calibrate the NanoVNA, the first thing we need to do is we need to set the stimulus to a start and stop mode. So we hit stimulus and we hit start. Now I'm going to be working down into the 80 meter band, which is around 3.8 megahertz. So I'm going to start this at 3.0 megahertz. And I'm going to do the stop. I operate up to the 10 megahertz band. So I'm going to stop this at 30.0 megahertz. All right, so I've got the start at 3 and the stop at 30, as you can see. All right. Now, to do the first calibration test, the first calibration test is the open. So as I told you before, we start with all these switches set all the way to the top. Next thing we do is we set the outside switches all the way down. As it says, measure is up and calibrate is down. Measure up, calibrate down. On these two switches, we set them to open, which is all the way to the top. which they are, and the middle is set for isolation, again, all the way to the top. All right? So let's start the calibration with the NanoVNA. Calibrate, calibrate, and click open. Now the next one, as you can see, is short. So now we've got to bring this back over here, and we set these two switches to the middle setting. Okay, now they're both set to short. So we come back here and we click short, and it does the test. Now the next one is load. So the next thing we need to do is set this switch and this switch to the very bottom, because that's what it says for load. Down, down, all the way. And we click the load. Now, isolation is the same settings on the board as load. So you just got to make sure that this switch is all the way down for load, this switch is all the way down for load, and this switch is all the way up for isolation, which it is. All right, so now we come back here, we click isolation. All right, the last test is the through test, and what we do is we click this last switch in the middle down to the through setting, as you can see right here, isolation and through. It's all the way down for through, and we click the through button, and then we're done. Click done. All right, and when I come back, I'll show you how to set up the rest of the NanoVNA. I'll be right back. All right, so now we have to set up the NanoVNA for the rest of the testing. Remember, we set it up for 3 megahertz start, 30 megahertz stop. Now we need to set up the traces. So let us go up, hit trace. Trace is 0, and we are going to go through the format S21 through, and we're going to set it for logmag. Now mine defaulted to logmag. That's what you want. You want to set it for logmag, and you'll see that it's now reading some dB. Next thing you want to do is you want to set the second trace. I'll use the blue one. And you want to come back and go back to format trace through. And it's also, you want to set that for, you want to go to more, you want to set that for series IZI. Well, that's series, that's for impedance. All right, so now I've got the blue set for impedance in ohms, and the logmag set for dB. Now, with the series impedance, you've got to go back and we have to set the scale for that. Now, the top, or I'm sorry, by default, the top will be 300 ohms and the bottom is minus 4,000 ohms. Don't care about the bottom, but the top I want to set it for 3,000 ohms, which I've already done. And how you do it is you say 3,000, enter. So now the ohms scale is set correctly. The logmag is set correctly for dB. Now we're ready to connect this back up to the Halibut test jig board. And we can start testing cables and chokes and all that kind of stuff. Now, that's how you get this thing set up. I'm going to do my next video. I'm not going to do it in this video. Next video, I'm going to show you how to actually start testing chokes. I've got 4 or 5 that I've either bought or made myself, and I'm going to show you what's good and what's bad. Now, before I do that though, just one last thing. We need to set all the switches all the way to the top. So all switches get set to measure, open, isolation, open, measure. All right, everything goes all the way to the top. Now I'll reconnect the NanoVNA. port 1 to port 1, port 2 to port 2, and I'll start testing chokes. All right, that's how you do it. That's how you get your NanoVNA set up. It's how you get your Halibut board set up, and we're all ready to go. I'll see you in the next video, and I'll be testing some chokes for you. This is Dave with Ham Radio GMRS Test and Review 73.